there, this video is going to go over two more examples of graphing linear inequalities, and as you can see by looking at these examples, they are not in slope-intercept form. So the first thing I need to do is get them into slope-intercept form. So when I start off with 5x minus 3y is greater than 15, the first thing I want to do is move the x term. So I'm going to subtract 5x from both sides. When I do that, I get negative 3y is greater than negative 5x plus 15. I still have a negative 3 multiplying my y, so to undo that multiplication, I need to divide all of the pieces by negative 3. The resulting inequality is y is greater than 5/3 x minus 5, where the y-intercept is the point 0, negative 5, and the slope is 5/3. So I start off by graphing my y-intercept of 0, negative 5. And from there, because my slope is positive, I'm going to move up or rise 5 units, and then to the right or run 3. So up 5, right 3. Put a dot, and I'm going to do that again. Up 5, right 3. I think I've got room to do it one more time. Up 5, right 3. Now as I reach for my straight edge, I determine that because that's a strict inequality, I have to make this a dashed line. Okay, got that all set. Now I need to pick a test point. My favorite one is 0, 0. And we do this to determine where this inequality is true. And I always put my test point back into the original inequality, so into 5x minus 3y is greater than 15. And the reason why I'm going for this instead of this, other than habit, is because when I plug 0, 0 into the original inequality, you're going to see in just a sec that the whole left side turns into 0. How convenient is that? And then that makes the evaluating this even easier. I get 0 is bigger than 15, which is false. So points on the 0, 0 side, so can we call that to the left of or above the line, result in false statement when you evaluate the inequality. And because my author tells me so, I'm going to cross out or shade the false side. Finally, my last linear inequality is represented in general form as 3x plus 4y is less than or equal to negative 2. Well, as we saw before, this general form is pretty handy for the test point, but we have to do a little bit of algebra to get it into the right form to graph it. So I'm starting by subtracting 3x from both sides, and when I do that I get 4y is less than or equal to negative 3x minus 2. And we divide all the pieces by 4 to get y is less than or equal to negative 3/4 x minus half. Now, don't be scared of the fractions. They're no big deal. First, we'll identify the y-intercept. No, we don't have room to do it there. Is the point 0, negative half. So that just means I go halfway down between 0 and negative 1 on the y-axis and put my dot. And then the slope is negative 3/4, which means from my y-intercept I need to move down 3 and right 4. And when I do this, I'm going to stay on the half marker. So I go down 1, 2, 3, and to the right 4. And there's my dot. And I'm going to repeat that. 1, 2, 3, staying on the half markers, and right 4. Now, as I reach for my straight edge, I look at the inequality. It's not strict. It has a partial equal sign in it. So I can use a solid line, just like I did when I graphed linear equalities. And the last step is, of course, to plug in a test point. 0, 0 is barely above that line, but it is above it. So that's a sufficient test point to use. And you know I refer back to the original inequality that I'm provided, so replacing both the x and the y values with zeros makes the entire left side of this inequality turn to 0, and I get that 0 is smaller than some negative, nope, that's false. So points above the line give us a false statement, and because my author tells me to, I'm going to cross out or shade the false sign.